Today I'm going to show you 8 things on how to use R inside of your company. I'll talk about things like working with databases or getting data from online storage, or how to store credentials and secrets, and how to manage multiple projects with RStudio or Positron. So a lot of this stuff isn't hard from a technical perspective, but it can feel intimidating when you've never worked with that before. So with that said, let's dive in. Alright, so the first thing that I want to show you is how to navigate between different projects. One of the first things you should know about inside of Positron, if you're using Positron to write R code, is that you can have multiple folders and then go through different folders here to jump between projects. For example, I could jump into this project here, or I could jump into this project here, and then Positron will jump into this project and it will open up all the files I've left open last time. The same thing can be done inside of RStudio. There you can use these RStudio projects to jump between different projects. For example, I could jump into this project and then there also RStudio would switch to a different project. So that's a great way to navigate between different projects, and more importantly, it is a great way to make sure that you're also starting with a clean slate when you're opening up your project. When you're switching between projects, you can be sure that what you've done in a different project, when you switch over to your new project or the one you need to work on next, then the different R sessions will not interfere with each other. You can see this most notably with the working directory. If you check for your current working directory, you will see that it is set to your current project, and this makes it really easy to work with files, and also it will help you to start with a clean slate. All of this is provided that you're not saving data in between sessions, and inside of Positron that's default. Inside of RStudio you will have to check in the options to not restore data and never ask for saving data. And if you make these changes, then you can be sure that your projects will always open up with a new fresh state. And if you have one variable called X in one project, the other project doesn't know about it, and this can save you a whole lot of trouble, because then your different projects are really completely separate and don't interfere with each other. So now that you can switch between different projects, let's talk about using packages in different projects. You might think that, wait a second, why do I need help with working with packages? After all, you can always just do install packages and then type in the package that you want, possibly tidyverse. That's cool if you've already worked with different packages and installed them to get them on your computer, but when you're working in a company that restricts the way you are allowed to download and access different packages, then this default way might not work for you. And then you're kind of left with figuring out, wait, I can't even install packages. How am I supposed to work? But the thing is, your company will probably allow you to use packages, but just some that were pre-vetted. And to fix this, to only access the packages that are allowed, you could, inside of the install packages command, say something like, okay, the repos, this is set to a URL where your company stores these packages. When you don't specify this, you will just download it from the internet, from CRAN. But if your company wants you to use something else, you'll have to put in the link in there. So for example, you could stick in the URL to the CRAN repository on the internet. If that works, that's fine, then you don't need anything. If this doesn't work, then you'll have to find out the URL for your company's repository. It might be called something like Artifactory, or it is from some different provider, or even like a custom solution. Your IT department can probably help you with figuring out what the correct URL is. Speaking about working with packages, if your company is a company that values reproducibility of the code that you write, and for your sake I hope that you are in such a company, then your company might actually like to use something that is called renv. It is a package that you could use, so you could just install it if you can install packages, and then use the renv package. And then with the help of this package, you can save different package versions for every project into a so-called log file. The log file looks something like this. Well, actually not something like this, it looks exactly like this. Here I've created a log file for my current project, which is just a specification, a JSON file if you will. If you've worked with JSON before, this is exactly the file format. If not, don't worry, I'll explain it to you. It's just the specification of the R version that you use. Currently I'm using 4.4.3 and the repository where packages are downloaded from. If you have access to the internet, then this URL will just be CRAN on the internet. But if you don't have access to the internet, then this will be the link to your company's repository. And then all the packages that you use inside of your project can be determined here. So here I'm using the DBI package with version 1.2.3, or I'm using the R6 package with version 2.6.1, and so on. So this kind of file documents everything you need to know about all the specific package versions that you need. With such a file, you can ensure that your code that is running today will also be able to run in, say, 2 years when you install the exact same packages using the exact same versions as you did today. So if you have such a log file inside of your working directory, you can just use the renv package and use the restore command to restore the packages. In my case, it will tell me that, okay, the pandoc isn't installed, and then it will tell me, okay, everything is already synchronized, so I don't need to do anything. Also, if I wanted to install a different package, I could just use renv install and say, okay, I want to add to my log file, I want to add, say, ggplot2. This is the package that will be installed. I'll say yes, and then it will be installed. And if I wanted to document it in my log file, I could do renv snapshot, but it was already inside of my log file, so nothing to change there. So that's a great way to make sure the projects that you're working on today can still work in 2 years, even if some packages have newer updated versions. So if you want to learn more about this renv package, you can follow along the link that should pop up right about now. It will take you to my video about this renv package and will show you how to set up your project in a way that you can use renv effectively. So we've covered how to install packages even if you're behind some company firewall, but let's also talk about the situations when your company actually allows you to circumvent the firewall. Not really circumvent, it sounds dangerous, but it allows you to access the internet via a proxy. This is a special server that allows you to go to the internet even though you are in a separate space. If your company does allow you to do such a thing, then your IT admin might give you a URL to some proxy. And what you have to do with that then is to call the sys.setenv command and set the HTTP proxy command to the URL of your proxy. So if your admin gives you something like this, you will just stick this into this sys.setenv command, and then you repeat the exact same thing for the HTTPS proxy, and then you can do the exact same thing but only with the all caps version of these variable names. It sounds stupid, but it's actually something that can be really tedious. Some systems want to have it in lower caps, some want to have it in all caps, and if you set all of them to this proxy, then you can be sure that whatever system you have, it works perfectly fine. And once you've set these proxies, so once you've executed this, it will tell me right now that it's missing something. That's because I had a comma too much in here, but now it has set this HTTP proxy, and now I could, inside of the install packages, try to check if it works now. Possibly I'd have to also say that the download method is something like wget or curl. You could just try these things out, whatever works on your system. Just know that there are some of these options that you could try to tweak in order to install stuff. I know it sounds like annoying IT stuff, but it is actually something that might become useful when you don't know how to install your packages. Now what we've done here inside of this sys.setenv command is set so-called environment variables, or env variables for short. This is something you'll often do to store secrets. But the thing that I have done right now, where I've just set the HTTP proxy environment variables to some specific value, this can be safely done inside of an R script like so, when it's not really a secret. But environment variables are often used to store credentials to specific services. And then you don't want to have these values inside of your R script like regular code, but instead you want to store them inside of environment variables that you can then access. For example, if I call sys.getenv and then look for the HTTP proxy environment variable, it will tell me that the value is currently the thing that I've just set. But still, this begs the question, okay, if I don't want to have secrets inside of my script where I call this sys.setEnv, where do I put the secrets then? Well, glad that you ask. We'll just have to create a new file, and this file is called rprofile, and I already have this file available in my directory. And inside of this, you'll see that the renv package has already created an .rprofile file to store some things that are supposed to be loaded whenever the project starts. And this is where we can also put in the sys.setEnv command. And then we just have to make sure that this rprofile file isn't inside of our Git repository when we use version control. So we could just create a gitignore and say that .rprofile should not be tracked via Git. So now we can put in any secret we want into this file here, and we can be sure that it won't be transferred to some repository. And also what is executed inside of this rprofile file, it's really hard to say rprofile file, but still my point here is whatever is executed in there won't be available inside of the session here. You see, R by default saves your history of what you've executed, and when you by accident publish your history file, then people could also get access to your secrets. But now that you've used an rprofile file that isn't tracked via Git, you're safe from that, and now you can safely put in secrets here. One scenario where you might want to do that is when you want to work with online data storage inside of AWS. In that case, you could store your credentials like the AWS access key ID and the AWS secret access key inside of environment variables, and you could also specify the default region that you use. Currently, I'm showing you these values here, but they are secret. The only reason why I'm doing that is because I'm deleting all of these secrets later on. So the moment you see this, they are not really useful. So I'm safe, and I can show you how to deal with these environment variables. So if I save this and then reload my session, and let me also remove these proxies here because I don't actually want them to interfere with my internet connection. Let's restore this session here. Now my session knows about these key credentials, and what I could do now to access, say, an S3 bucket to access data that is stored there is I could use the pause package. So let's call library pause, and then inside of S3, which is an AWS service to store a lot of files, you could see that I have a so-called S3 bucket called freemw pins test, where I have some directory called penguin, inside of which is another file, and in there is an RDS file that might contain data. So the path to this on my S3 bucket is this URI here. So my file is stored at this location here. So let's take this, and then let's just copy this in here and extract the information that we need from that. So what we can do now is to save a variable called bucket name, also object key, which is just the rest of this path here. And then we want to specify a name for the file that is supposed to be used when it's downloaded to my computer. And then using the pause package, I'll just create a so-called S3 client. So a service that can interact with the S3 bucket to actually download stuff or upload stuff. And with this S3 client, I can create a response variable, just a variable that I store things in. And there I just use the S3 client and its getObject method to, from my current bucket, get the key that I've specified via object key. And once I do that, you'll see that here I have some cryptic stuff in here. And if I scroll further up, I see that it also has a body, and this body is what is binary code for the actual file, so we have to translate this. So there we check whether we actually have a body. If not, we'll just throw a warning. But since we already know we have something like this, we can just write a binary file using the body to our current path where our file is supposed to be. So if we execute this now, we see that, okay, the file was downloaded successfully. We also see that here's our RDS file, and now I can just read it in here. And if I execute just this part, you see that here I have my penguins. Let me make this actually a little bit larger. So there is my data set. Let's actually make this into a tibble so that the formatting is a little bit nicer. And there you see that we have my data set now. So basically we have downloaded data that was stored on some online cloud storage called S3 to our local system, and now we have that data and can work with this. As you can see, the workflow isn't too hard once you figure out how to deal with all of the moving parts of setting credentials so that PAUSE can connect to the service using this S3. PAUSE immediately checks whether there are these environment variables, AWS, access key ID, and so on. And once it has that, it will just download the file as a binary, and then we can also read the file on our computer. If you're not using AWS or S3, there are similar cloud storage providers that do the exact same thing, and the system is also kind of the same. There will likely be a package that allows you to create a client, like we have done here, to interact with the service, and then there will be some method of the client to download things from your cloud provider. You'll have to check the documentation then of that package, how to actually fill the parameters it needs. I know, not really fun to work with the documentation, but sometimes it is what it is. Now, if you've liked this video so far, make sure to give this video a thumbs up. This helps me to know whether you actually enjoy this content, and it also helps me to grow my channel. Also, if you want, you could also subscribe to this channel to get notified when I create new videos like this. And in any case, your like and your subscription really helps me a lot. So thank you for that. And now let's get back to the video, where I want to show you how to make this process of downloading stuff from S3 even easier. You see, there is a package called pins that makes it even easier to work with online storage like S3. So if we load the pins package, then we could create a variable called board. Pins uses the terminology board to store data on, and then you can create a board for, say, the S3 service. There are other board functions for other services, and then you just specify the bucket name and the region name, and once you've done that, you will have a board. Right now it doesn't tell you much, but if you're using the pin list function, you'll see that I have a whole bunch of pins, including the one that I've just downloaded manually from. But if I wanted to use the pins package to do that, I could use the pin read function to read this particular pin. And there you go. You'll see that you have a data set right inside of your R session. And there's also a pin write function. And the nice thing about this pin package is that there is automatic versioning so that you could, for example, access the data set using a timestamp from last week. So the pins package is really convenient for this kind of data storage thing. And if you want to learn more about it, you can check out my video about the pins package. There should be a link popping up right about now. But even if you don't check out this video, which I don't say you shouldn't do, you should definitely check out the video. I'm just saying, even if you don't check out the video, you've just noticed or you've just learned the glimpse of how to work with this package, and you've already seen how easy it is compared to manually downloading stuff. So when you have the option, I'd go for using pins instead of using this manual route here. Finally, let us round off this video with knowledge about how to work with databases. Databases sound like something that is intimidating, that you don't know how to handle, but when you can handle a data frame like this, then you can most certainly also handle SQL databases. You just have to know your entry point to databases, basically. You see, inside of my Explorer, you see a file called SQLite. This is basically a database just stored locally right now, and we need to establish a connection to this database file, and then we can work with this database using SQL code from inside of R, or we use dplyr syntax that makes it even easier for us to just use our regular code that we normally would. And inside of your company, you'd usually not have a SQLite file like this, but you'd establish the connection using some connection details, but the principle is still the same. So let me show you how that works. So what you do is you'd save your path to your database inside of a variable. When it's a real database that is somewhere in the internet or somewhere within the network of your company, you'd have a URL instead of a file name here, but the idea is the same. And then you'd establish a connection using the dbconnect function from the dbi package. And then you specify that you're using a so-called ODBC database driver, just using the ODBC package. You'll have to make sure that on your computer your database driver is installed, but if you're using cloud infrastructure from your company, then likely the IT department will have done that for you already, and you'll just have to specify the driver name. In this case, I'm saying we need a SQLite database driver because we're having a SQLite database. Again, if someone tells you to work work with your database, just ask what kind of database do we have, possibly something like Postgres, then you'll put in Postgres in here instead of SQLite. And then you just tell this dbconnect function where your database is located at, and once you have executed this, you have a database connection to your database. So that's really how you'd establish a connection to a database. When it's a real database in the network, then you'd have additionally to this database path, you'd also likely have something like username and password, but the idea is still the same. You can all just throw this into this dbconnect function. And then you could just take your connection and use the dbgetQuery function from the dbi package, and then stick in SQL code like select title and price from the books table, and this will give you the data from your database. But if you don't like using SQL or don't know how, then you could use your regular dplyr code. You see, what you could do is write a books variable that's a table from the dplyr package that just establish a connection to the books table inside of your database connection. And once you have that, you will be warned that apparently I don't have dplyr on this project, so I'll just use rnf install to install it. I guess I have forgotten to install it. And now that it is installed, I can see here that it will ask me, okay, we also need the dbplyr extension for this database stuff. I'll say, yeah, let's install that as well. And once this is finished, we can execute this code, and we'll see here that really this is just like a regular table, except for it tells us that it is connected to a database. It is a table called books. It doesn't tell us how many rows there are, because in a database there could be thousands, if not more. So that's why it just shows us a preview here. But the nice thing is that this table preview works like any other data set, in the sense that you can just throw your dplyr code against it with select, and then if you want to get all the data, you will have to collect this stuff. So let me throw in the dplyr package here as well. So there we just collect the regular table. After this collect call, everything is just a local table on your computer. So with that, you're set to also work with databases. Of course, there's lots more to learn about how to connect with databases and how to kind of use SQL or this dbplyr extension to deal with this. If you want to learn more about this, I have 2 videos about this. You can check them out via one of the links that should pop up right about now, or via the links that are in the description. And with that, we've also learned 8 things that you can really use when using R in business. Let me know in the comments if I forgot anything crucial. I might add it in another video. Don't forget to hit the like button. And now with all of that said, I say thank you for watching, and I will see you next time.